All right, that's the only type of, I want a chance to work another problem, but before I get there, on page 35, let me ask this. Is there anything on your homework that you're unclear of as far as setup? Any question, and I will run through the setup on it. So, anyone? Number one, y'all get on setup on it. Number two, number three, number 4, 5, 6, 7, 8, 9, 5.
Can we do number 3?
3, yes we can. Okay, 3. So a machine part is indicated in figure 9.30. Find the distance from the center of the holes represented by lengths x and y. And you don't have that figure, right? Wait, where is that figure? Oh, very below. Sorry. Right below it. I'm sitting there looking for some machine part, like a circle that's got bolt holes on it. So it's the figure right below it. So you want the distance between the center of the holes represented. In essence, we've got our triangle given to us, it's this one. Okay. The distance between the center of the holes represented. So we're really going to need 2 here. Okay. We know that we have this distance from the center of this hole to this hole. That one's already given. We need the center, the distance between this hole and this hole, and this hole and this hole. So in essence, you're going to have to do 1 trig and probably the Pythagorean theorem on this. So the first thing you would do is, let's say, okay, since I know this angle, I'm going to be dealing off of here. So I know this center. So let's go ahead and find this one. So let's find x. Now if I do that, then this is the hypotenuse, this is the adjacent, and this is opposite. Now if you go through SOHCAHTOA, that's going to basically tell you that you have the tangent of 38 degrees is equal to x over 7.8. And that will give you this side. Once I have that, I can turn around and do trig again for this side. But since I have hypotenuse in either one of these, I can use cosine or sine. Because all I'm looking for is the hypotenuse. Both of those are part of it, and I know everything else. Or you can go to c squared is equal to a squared plus b squared, because you know both of these sides. And that would solve for the missing side. Okay. Does that answer your question?
Mm-hmm.
And I don't want to work the problem for obvious reasons. You are getting graded on the homework. Any others? 4?
No, but 5 just,
Okay.
so it's 177 feet long.
Mm-hmm.
And so then I'm going to go up 50 feet from the ground.
Yep.
And that's the angle I'm looking for.
The conveyor runs this way. You are given the length of the conveyor, which is your hypotenuse. You are given this side, which is 50 feet. Okay? These are all feet, by the way. And at what angle relative to the ground? So what you're looking for is that angle right there.
Okay, so I had 170 feet on the bottom,
Okay.
but it's not.
No, it is the conveyor.
Okay.
where this guy right here is your conveyor. Okay? All right,
Okay.
number 6, 7, 8, 9, and the last one, 10. No questions on 10, huh?
I haven't gotten there yet. I don't know. It looks like I will. So
Ask me
it's 2
individually.
triangles.
Ask me individually.
What?
Ask me individually then,
Okay.
if you have questions on it. Certainly, we can use any of that. We've only got about 10 more minutes. So let me just, let's do this as a group deal. I need to do a tech sketch of that wall right there. Okay. Now the reason I want to do that is because I want to put some windows in that wall. And I know if I leave this roof this height, I can't put windows over there. Okay. Now we're limited. We've got a HVAC trunk line running behind that ceiling right above Declan, Missy, and Juan's head. You can see the diffusers coming out right above you. So I can't get closer than that. What angle do I have to run that roof to get that window in?
Right there.
Now, we've got it sitting here for us,
It's right
but if I
there.
had to draw it, if I was using this for a design problem, this is what I would do. I would start playing with different angles based on that trunk line to know, hey, I want a 3-foot window, 4-foot window, what angle do I have to put that? Now, you've got a sitting example for you. How are you going to figure out what that angle is? I've got a tape measure. Can we do it?
I've got an app.
How are you going to do that without any measurements up?
I got the
You twi-
blueprints
you-
back
you-
here, I
you
can
line
tell
it
you.
all up and you twist it left and right and it tells you what the angle is.
Awesome, let's use that app.
I don't know if
Let's
it's
see how
actually
I
better or
can
not.
do
I
this.
used to use it all the time.
Okay, so let's figure out, I've got a tape measure, how are we going to define that angle?
I-
What do we need?
Where are you putting windows again?
I'm gonna stick them right there, but you're just gonna draw this in so you can figure out how high a window you can put. Okay, how are we gonna figure out the angle of this roof? I'll give you a hint, you're using Trig. So we can measure stuff, right? So Declan, you can measure from there to there, right? Okay. So let's just kind of sketch this. I'll sketch it on the board and you guys give me the angle measurements I need to figure this out.
No.
So here's my wall
Oh,
with the angle
oh, you.
and my other wall. Okay. Now in essence, what I really have here is I know I need this, right? I need that angle to accurately draw this thing. Okay, so what'd you get for measurement?
113 inches?
I'm sorry?
113 inches?
Okay, so we know this is 113 inches. Andy, if you want to use your app separately.
Yeah, I must have.
Now what are you going to do, Declan? Going to measure that wall?
If it were me, yeah,
Yeah.
you need to measure all the way.
I took the trash can out of the corner so you can use the corner if you want. No?
Nope, up the top of the window. Sorry, okay.
Yeah, it's good.
That's like 4 or 11 feet. 3 inches.
11 feet, 3 inches?
11 feet,
I
3
just
inches?
measured right there.
Yeah.
The little short bit of it is.
I can't get up there.
And then, 'cause that's a lot of math.
Okay, we'll convert that back. Okay, so we got that. Do I have enough on this to now run Trig? If I got to draw this as part of my job, remodel.
Yes?
Yes. You know, you can also.
No,
No, you don't.
no, we need one, we need
We need this, we need.
We need something else we can get.
So if it were,
Yeah.
you can do the out from the wall to wherever it was you measured from.
Mm-hmm.
Would be a nice simple one. You just lay the tape on the floor from the wall out.
Yeah, there. I can't remember where exactly.
Smart people mark where they do it to start with. Look, I've made the mistake before.
140 inches. Hey, you should use your app though and just see how accurate it is.
Can somebody give me this number? What's 11 times 12?
132.
Somebody confirm that, please. I
Yeah.
think Andy did that in his head.
Yeah.
Yes, I did.
It is good.
Okay, so now we're putting into inches. Now, do we have enough information here? 135 or 140, sorry.
Yes.
140. Do we know this?
Yes.
13 would be 32, 22. Please, somebody check my math.
22.
Okay. Now, can you calculate that angle? Adjacent, opposite, that's tangent. Tangent of some angle is equal to 22 over 140. Or the angle is equal to tangent to the minus 1 over 22 divided by 140. Oh, wait. Can I get somebody to confirm that number? Now, based on, we weren't very accurate with our measurements, I would hesitate, I would basically say this is a 9-degree angle. Now, based on that also, and I say, you know what, I want that window, I need enough room for a header, so I can now calculate any type of window I want in there, and I know where the height could go, and say I need a 2x6 on top of it or something like that.
No, the app calls it 9 degrees.
What's that?
The app calls it 9 degrees.
Okay.
No way.
Yeah, you want to see?
Yeah.
Look. Okay, so you line it up, right?
Cheater. This is good.
Run it through your app there.
I'm
Okay.
liking this app.
All right, so what you do is you get it up there, right? You get it under level point. Okay, you can see the lines going through it, right? It's pretty much level. You twist it up to where you have your things, and it spits out 9 degrees when I actually hold it still. It goes between 8 and 9. That's about as accurate as
It's much
any
better.
construction person's
That's
ever going to get.
insane.
You know how we used to do 412s and 512 rusts without measuring them? We'd hold up a bunch of templates. Matches that one, nope, doesn't match it, pull out another one.
Oh, we just hold up a level on our roof and then stick a tape measure up to it. And
Did you get the degrees?
I did, no, I got 9.09.
And-
That's-
What did you have? You got 9 degrees.
Well,
It's
more
a decimal
close.
point thing.
but then I got 9.09 and then I put equals and then it keeps coming to 1 point.
What is your-
something.
Okay, what you
Angle
wanna
Pro?
do on your calculator
Can you
is
see the
take
icon?
22 divided by 140.
No, the icon of
And I
it,
got
of this,
1.16.
no, the,
Okay, do it on your calculator.
I like,
And we're not gonna delete any numbers out. 22 divided by 140 equals.
Right.
Okay.
And
Now,
so I-
now, before you do anything else, hit your second function, arc tangent. That's your answer,
That's 8.93.
okay?
Okay, so you can't, so I got the 0.16 or whatever, and then I cleared it, and then I times it by the second tan, and that's when I got the 9 point something and then equals and then 1. So I can't get out of that. I have to
No,
keep
you can
going.
get out of that you hit the equals one too many times, though.
Hmm.
Okay, you had- that 9.02, that's the correct answer. but now you're using 2 decimal places versus before you used 8.
Uh-huh.
They're both right. It's a level of accuracy. You need to get on the road, Declan. If you need to go, go.
Okay.
So in essence, that's it. Now, you can get a bunch of different machines. So
To where?
Andy showed you an app. It might be downloadable for free.
It is. And actually, you should download the DeWalt construction app. It's free too. It does all of your unit conversions into square feet, cubic feet, everything else. It was something I had downloaded a long time ago, and it does everything for you.
Now, there are other things you can do out there. They make a specific machine called a clinometer that will actually measure any angle, and it gives you a scope to look through, and it is extremely accurate. I use a Brunton on my angles, which is a geologic tool that I've got sitting in the glove compartment of my truck. And it does the same thing. It's accurate to 1 degree. Okay, you're probably accurate to about 1 degree on that guy. So it depends on the level of accuracy you need. But certainly, if you're out doing a technical sketch of some structure, this is a real quick way. Get a couple base measurements, a little bit of trig and a calculator, and you can draw things to scale in the field very quickly. The pop quiz you did, I got all that information straight from pacing and using my Brunton. And that's what I use as my base information. You're plus or minus 2 feet on the height of that tower. So keep that in mind. My goal here in this class, if you don't learn anything else, is that you know right triangle trigonometry. You can go out and pull it in the field, because you can, with a little imagination, you can make anything on this planet into a right triangle. Like center of bolt holes, property lines, structures, topography of soil, all of that can be converted to right triangles and solved. That's it, that's all we got time for today. Now, next week, your assignments are due.